Solving more logarithmic equations. This is in your notes, page 6. The learning target is I can solve for log equations that involve more steps. Go ahead and play this. Okay, so solving for x in these log equations involves a little bit of more steps. And I'll show you an example here. This log equation, in order to solve, we want to first convert this into its exponential form. So I'm going to start at the base. It's going to be 5 to the 2x plus third power equals 25. So that's what this looks like. In order to solve for this equation, we're going to be using the equal base theorem. We got to make this 25 look like a 5, or have a base of 5. So I ask myself, 5 to the what power is 25? 5 to the squared power gives you 25. Once your bases are the same, you're going to take the exponents and set them equal to each other. Now you just solve for x. So I'm going to subtract 3 from both sides. You get this, divide both sides by 2, and you are done. Example 2. Now we're going to take a look at a different type of problem. The first step is usually the same. You're going to rewrite this in exponential format. So it's going to be base 2 to the 2x minus 4 power equals 1 over 8. And this was using the little loop trick. Okay. So now I want to make sure that both of these sides have a base of 2. So what I'm going to do next is I need to bring this 8 up. So there's a rule to bring this 8 up. I make its power -1. Because this was 8 to the first power, to bring it up, you turn it to 8 to the -1. So that's step 1. I had to bring this up. Next step, I want to ask myself, 2 to the what power is equal to 8? 2 to the third power is equal to 8. The next step is we're going to do 3 times -1. There we go. So once we multiply these, we have the same bases. Now we could take the exponents and set them equal to each other. Now we just solve for x. So all I'm going to do is add 4 to both sides to get x equals +1. Example 3. So again, this is very similar. We're going to start by, at the base, do my little loop trick. So it's going to be 27 to the 2x power is equal to 1 over 9. Okay, so my first thing is I want to make sure I bring this guy up. I imagine that this is to the first power, so that to bring this up into the numerator position, I'm going to make it 9 to the -1. Okay, so this is where my step might get a little different. This is base 9, this is base 27. I can't make 27 have a base of 9 because I know that 9 to the first power is 9. 9 to the second power is 81, not 27. So what I'm going to do is I know that 3 goes into 9 and I know that 3 goes into 27. So how about if I make both of these have a base of 3? Because I know that 3 squared gives me 9 and I know that 3 to the third power gives me 27. I can make 3 work. So I'm going to go ahead and rewrite this. So this is going to become 3 squared, and this 27 is going to become 3 to the third. I rewrote them in parentheses so that you can see that. What I'm going to do in my next step is I'm going to multiply these two. So this is going to become 6x. This is going to become -2. Now that I have it written like that, I could go ahead and set the exponents equal, because now that the bases are the same, by equal base theorem, I could take the exponents, set them equal to each other, and solve for x. So now we just basically got to divide both sides by 6 to solve. And this can reduce, I wrote this as my final answer, but this can reduce to -1/3 as well if you cancel out a 2 from the top and a 2 from the bottom. That's it for example 3. Alright, example 4 has a slightly different format. Let's go ahead and see how we solve this. Again, I'm going to do my little loop trick and I'm going to rewrite this as an exponential. This one is very different. This one we are not going to force each base right here to have a same base. We're not going to force the bases to be the same in this case. We cannot actually, because this is 7 times 7 and this is 3. It's not going to work. What I'm going to do in this step is going to get rid of this squared. To get rid of the squared, I could raise both sides to the, I could raise both sides to the 1/2 power, because 2 times 1/2 is just 1, so that's going to give me 3x to the first power, which is just going to give me 3x. Basically, if I raise both sides to the 1/2 power, I get rid of this squared. This is also the same thing as taking the square root of both sides, by the way. But anyways, so this right here is going to make this whole thing disappear or cancel out. You're going to just have 3x, and over here you're going to have 49 to the 1/2. Okay? So now I got to find out what 49 to the 1/2 is. So at this point, you could use your calculator and just put 49 to the 1/2 power, or just take the square root of 49, that's 7. Now to solve for x, divide both sides by 3, and you are done. So that is example 4. The task that you will get for this example set is going to be very much modeled according to the examples. So please use your notes in order to do this task.